Hello class, and welcome to Unit 4, which is probability. Today we're going to do an intro lesson which is called Basic Probability, Lesson 4.1. Alright, I want you to think about in the real world, where do you see words that are used to describe probability? Okay, so what are some of those words that we see? Okay, we see a chance. Okay, we see a likelihood. And we use a word called odds. Okay. Now, probability can be used in regular sense in terms of weather. Probability can be used to describe a possible outcome. So, for example, if you are dealing with a surgery or an illness, the doctors might give you, a percentage or a chance that this could occur, or side effects, etc. Okay. So where is knowledge of probability important in the real world? Well, first of all, I just said weather forecasting. For example, there's a 50% chance that it's going to snow today. Where is it helpful for you? In the stock market. Okay. Some people make a living off it, but not most people, but gambling. Okay. Especially with cards, you need to know the probability of a card coming up that you need. Okay. Experimental studies is another one. And I will put down here that in the medical field, it's important to know like the likelihood. So for example, say someone gets diagnosed with cancer, what's the chance that it'll reoccur, etc. like that. Okay? All right. So, and I don't wish cancer on anybody, by the way, but it's just something that's touched me recently in my personal life, so that's why it's on my mind. Okay, so probability. Probability is the quantified measure of the likelihood that an event will occur. Okay, and we use, for example, what's the probability of rolling a 1 on a die? So probability, capital P, of rolling a 1. Well, the probability of rolling a 1, there's one side of the die that says 1 over how many total sides? That's 6. Okay, so that's an example of a probability question, but we'll get to probability notation a little bit further on. Okay, how do we measure probability? Probability is measured either by a decimal, a fraction, or a percent. Okay, ranging from impossible to absolutely certain. Okay, so if we took a look at a decimal, it's going to be 0 to 1. Okay, 0 meaning I'm not breathing. So that's impossible because otherwise I wouldn't be talking, right? And the absolute 1 meaning I am breathing. Okay, absolute certain. Okay, same with a fraction. It can be 0 over 100. Okay, to a total possible 100 over 100. Okay, and again, reduce fractions to lowest terms always. Problem is, if I reduce these to lowest terms, folks, they wouldn't be fractions. So in your real example of your answers, make sure you put them to lowest terms. And lastly, and this is most common usually with weather forecasting, the percentage. So you can have 0% to a total possible 100%. Okay, what's the likelihood of there being oxygen in this room right now? Absolutely 100%. What's the likelihood that right now when I'm doing this video that I'm in Jamaica? Absolutely 0%. Okay, so there's some examples that have the extremes in them. Okay, so let's take a look at this example here. Okay, probability of getting a jack from a standard deck of cards. So hopefully you remember a standard deck of cards has 52 cards in it. Okay, all right, but we don't want all the cards, we just want specifically the number of jacks. So N means number of jacks. Okay, so in a deck of cards there are 4 total jacks. Well, how many cards are there total? So the number in the sample space equals 52. That's just a little bit of prep work to get us ready. So now we want to do the actual probability of getting a jack. Okay, and if you don't like the J, you can write the word jack out, that's fine. Okay, equals the number of that specific outcome, which is the number of jacks, divided by the number in our total sample. Okay, so it's desired probability over the total possible outcomes. Okay, so we're going to write 4 out of 52. Use your fraction button on your calculator to reduce this, and don't forget, always put it into lowest terms. Okay? Perfect. Okay. Now we're going to go over some different types of probabilities here, folks, and I'll give you an example for each. So, subjective probability is where the probability is based on intuition and experience. Okay, so the prime example for this is a weather forecaster, especially if someone's tracking a possible tornado, for example. They have some intuition of what the weather patterns look like to make it, or a big storm front coming in. Okay, that's based on intuition and experience. Okay, another type is called experimental probability. This happens when you actually perform an experiment. Okay, also in your textbook, this is called empirical probability, or another term that's used is relative frequency. Most often or not, you're going to see experimental or empirical, though. Okay, all right. So an example of this is, say I ask you to roll a die 20 times, and you're actually going to perform it yourself and record the number of times a 6 landed up. Okay, all right. And folks, this is similar to when you did your survey. Okay, when you did your survey, you performed that, you found the results yourself. Okay, and hopefully you remember that the larger the number of trials, so in this case, the number of times you roll the die, or in your survey case, the more surveys you do, the closer your results will be to what we call the theoretical probability. And that's what we're going to deal next. Okay, it's the most important one, and I'll tell you why in a second. Okay, so you want to get as close, in real life, if you're doing an experiment, you want to get as close as theoretical probability. And the reason why, folks, is the definition of theoretical probability. Theoretical probability is based on laws and formulas, okay? This uses different types of organization tools like tree diagrams, outcome tables, and organized counting, like what we just did with permutations and combinations. Okay, so by law, this is the formula we just did up above, folks. Okay, so probability of getting a jack is the number of jacks divided by the number in the sample. So number of A is the number of ways the event occurs. So number of ways the events occur. All right. So the previous example, we just we looked at the number of jacks. Okay. Number in the sample is the total number of ways. Okay. Whereas P at A is the probability of the event happening. So use prob for the short form. Probability of the event occurring. Okay, and this is where we're starting our unit. Okay, so let's take a look. What is the probability of rolling a 5 on a die? Well, number of 5s on a die is 1. Okay, number in my sample is 6, and S is for sample. I know sometimes it looks like a 5, but S is for sample. Okay, all right. Probability of rolling a 5 equals the number of 5s over the number in the sample. Okay, plug it in, it's going to be 1 over 6. Eventually, you guys can get from the probability to here, but we're just introducing it, okay? Awesome. Okay, now let's take a look at the opposite. The opposite is the complement. Okay, so sometimes it's beneficial to find the complement, okay, of the event. And can you just put down to find the complement? Just have a typo there. Okay, so find the complement of an event. Okay, so the complement, something not occurring or prime. Do you guys remember that as prime? Okay, equals 1 subtract the probability of it happening. Okay. All right. So if you take a look here, if we relate it to like a Venn diagram. So a Venn D, okay? If it's happening, it's inside the box. If it's not happening, it's outside the box. Okay? And one thing to remember, the probability of it happening plus the probability of not happening equals 1. So we just switched it around to get that formula. Okay? So let's take a look at this. Probability of not rolling a 4. Well, if we take a look at a die, number of 4s equals 1. Okay? Number in our sample space equals 6 sides, right? Okay, so let's do the opposite. Probability of rolling a 4 equals 1 over 6. So now when we do probability of not 4, which is the opposite, okay, that equals 1 subtract the probability of a 4, which we already calculated. So 1 subtract 1/6. Use your calculator or just your brain on that one, which leaves 5/6 left. Okay? All right? It's kind of like the indirect method, guys, if you want to think about it that way. All right, last question. What is the probability that a randomly drawn integer between 1 and 40 is not, so I would underline whenever you see not, a perfect square? Well, let's just quickly review what are our perfect squares that are between 1 and 40. So 1's a perfect square, so 2 squared is 4, 3 squared is 9, 4 squared is 16, 5 squared is 25, 6 squared is 36. Now, if I went one more, 7 squared is 49, so that's too much. Okay? So the number of perfect squares, PS in this case, okay, equals, count them up, there's 6. Okay? Number in my total sample, that equals 40. Okay? So what's the probability of getting a perfect square? Okay, it's 6 out of 40. Reduce that to 3 out of 20. Okay? Now let's do the complement. So probability of not perfect square equals 1 subtract the probability of a perfect square. Okay, so it's going to be 1 subtract 3 over 20. Use your fraction button in your calculator or your brain, and it's going to be 17 out of 20. So here's our first crack at probability, ladies and gentlemen. Hopefully you had fun. I enjoy probability. I think it's great. And I think we do see it in society a lot. So here's our homework today, page 312, numbers 1A, B, C, F, 2, 4, 6, and 7A. Have a great day, folks, and please come see me if you have any help with probability.